Hi everyone! In this video we're going to go over the example flowchart in your lab procedure handout. This example flowchart is different from what you'll be doing in the lab that we're performing, but it's really similar, so we're still going to go over it. And then after we've gone through this flowchart, I'll show you the layout for the flowchart for this lab, so that can kind of get you started. And you will have to turn in the flowchart with your lab notebook page pictures that you turn in. It's going to be worth part of your lab report grade. All right, so this flowchart is based on the extraction described on pages 123 to 125 in the Zubrick Lab Manual that's on Canvas. So in that example, we're trying to separate 4 different compounds that are in a mixture. So we're trying to isolate each compound. And we're going to do that using extractions and washings, etc. So you'll notice that each of these compounds has a different functional group attached to a benzene ring. So the first molecule, benzoic acid, has a carboxylic acid group. The second molecule, anisole, has an ether group. The phenol molecule has an alcohol group. And p-toluidine, I think that's pronounced, that has an amine attached. So the first thing we'll do, because this is likely a solid, we're going to dissolve everything in diethyl ether. And then we're going to place that solution in a separatory funnel. So you'll have one layer to start. You'll have just an ether layer. But then you're going to try to extract one of the molecules using hydrochloric acid. Now this is diluted hydrochloric acid, so it's only 10% hydrochloric acid, but we're going to extract this molecule twice just to make sure that we extracted all of that molecule. So once we add the hydrochloric acid, we'll have 2 layers, and it's up to you to figure out which one is which, although it's kind of given away in this chart. So you'll have an aqueous layer with the acid and one of the molecules from the mixture, and then you'll have an ether layer with the other 3 compounds left behind. Now when you add hydrochloric acid to this particular mixture, it's only going to react with the amine group. So we end up with NH3 plus on the end and the chloride ion. So we form a chloride salt. So what we'll do is we will collect the aqueous layer, which contains this compound, and then we need to turn it back into its original form, so the amine. So we'll have to add base, NaOH, in order to turn this back into NH2. So we're taking one of those hydrogens on the NH3 group. And then we'll use the necessary steps to isolate the solid. Okay, so I told you earlier that the answer to which layer is which is given away here. So the upper ether layer contains the other 3 compounds. So now we have to try to remove yet another molecule from this mixture. So in the next step, we're going to add saturated sodium bicarbonate. So when we do that, the sodium bicarbonate is going to react with the carboxylic acid, and it's going to form a carboxylate salt. So we're going to collect that layer, And then we need to turn it back into the carboxylic acid. So we're going to add acid. So that will add a hydrogen back onto that group, and we'll get our original molecule back. And then we'll collect the solid in any way we need to. So then again, we'll be left with that ether layer, and now it only has two molecules in it, phenol and anisole. So how do we separate these two compounds from each other? Well, we're going to do another extraction using 10% sodium hydroxide. And the sodium hydroxide is going to react with the alcohol group. So we'll end up with an ion again. And then we're going to add acid in order to turn it back into the phenol compound, so that oxygen will grab onto a hydrogen. And then we'll use the necessary steps to isolate that. And then now in the upper ether layer, all we have left is anisole. So we can just do whatever steps are necessary to turn that back into a solid or a liquid or whatever it is in its natural state. Okay, so in the lab report, you're asked to create a similar flowchart. So let's go over an outline for that flowchart. So let me go to Word document here. So we're going to do something pretty similar. In our experiment, we're starting with only 3 molecules. So we're starting with trans-cinnamic acid. And notice that this also has a carboxylic acid group. We're also starting with 4-phenylphenol. And notice that that has an alcohol group. And then finally we have nicotinamide. And this has an amide group, which is pretty similar to the amine, but notice off to the side, we actually have a nitrogen. So that could count as our amine. All right, so let me write each of the names down here so we know which is which. Oops. Okay, so we're going to try to separate these 3 molecules from each other using similar methods that we saw in the example flowchart. So again, the first thing we're going to do is extract with 5% HCl. So our procedure is a little bit different. And we're going to do that 2 times. So at that point, we'll end up with one of our compounds that's isolated, and then that will be in the aqueous layer that we collect. And then in the upper ether layer, we'll still have 2 compounds. So you'll need to figure out which compound is going to react with hydrochloric acid and be extracted from the ether layer. Now, because we're isolating an aqueous layer, you're going to neutralize that layer, but you have to figure out if you're going to neutralize it with hydrochloric acid or sodium hydroxide. So I'll just write down here HCl question mark, NaOH question mark. So you have to figure out which one you have to use there. So once you neutralize that molecule, you'll have the original molecule. And then you have to figure out if you're going to, or what steps you're going to perform from there to isolate the solid. And you can either watch the video that I put up online of the lab, or if you perform the reaction in lab, you can complete your flowchart from there. So those steps might not be completely obvious until you've either watched the video or have done the lab yourself. Okay, so next we have, again, 2 compounds in this box, and you have to figure out which 2 are left in the ether layer. So we're going to perform another extraction to try to separate those 2 compounds. So we're going to use saturated sodium bicarbonate. And this will be 5% as well, and you're going to do that 2 times. So we could even add in 5% sodium bicarbonate. So you have to figure out which of the 2 compounds sodium bicarbonate reacts with. And this will be very similar to what we saw in our example flowchart. All right, so that will separate our last 2 compounds in the mixture. And then one of those compounds will be in the aqueous layer, and one will be in the upper ether layer. So the compound that's in the aqueous layer has gone through a reaction, so it will look slightly different, similar to the example flowchart. So we'll have to neutralize that as well. And it's up to you to figure out if you have to use hydrochloric acid to neutralize it or sodium hydroxide to neutralize it. And then that will give you back your original molecule that was in the mixture. And then from there, similar to above, you can figure out what steps you have to take to isolate the solid. Now, with our last compound that is left in the ether layer, you also need to figure out what steps you need to take to isolate that solid. And again, you can do this by either watching the online video that I posted, or you'll figure it out when you get to lab. You can also read through the procedure and kind of figure out what those steps are too. Okay, so our flowchart again will look something like this. You just have to fill in which compounds are extracted during each step. And then you'll also need to figure out the steps taken after you've isolated the compound so that you can actually get back the solid. So if you have any questions about this flowchart, just let me know. We can walk through it together. But otherwise, have fun trying to figure out this puzzle. This is something organic chemists have to do a lot. They have to separate mixtures and isolate compounds of interest because unfortunately a lot of compounds are not found in their pure form in nature. So we use these types of methods to isolate the ones that we want. All right, good luck.